السلام عليكم سلاو عزيزان الحمد لله لو أنا شكاهاتي نولاتان so ئاگاداربوون إن شاء الله با chapter يكم تعادكين we will terminate chapter 1 إن شاء الله but there is a question أو برسالة درس الرابط بزمان يشتوي سبارة the practical and theoretical results so برسالة حل دكم then directly I'll be explaining the osmotic pressure, the experiment of the osmotic pressure and osmosis process. Okay. So first, as I said, let's solve this question related to the practical and theoretical results, their effect, I mean. We have a question 11. In my booklet, it's in chapter review also. The question is very good, really. It's a good question. Experimental data for 1 molar MgI2. So we have a solution of 1 molar MgI2. Be careful. First of all, where's MgI2? Mr. MgI2 is a salt. Yeah, great. Salts are electrolyte or non-electrolyte. Remember? Electrolytes. Great. They're electrolyte. Well, so we have a 1 molar aqueous solution of MgI2 magnesium iodide. Indicates an actual change. It has been observed that an actual change in freezing point. Actual, it means practical. Look, the experimental data. This is the experimental. Experimental, it means practical things that are going to be done in the lab. Must be experimental, must be practical. Okay, the change in freezing point. Change in freezing point, it means delta TF, but this delta TF is a practical one. Is equal to negative 4.78. So delta TF, practical one, equals to negative 4.78 Celsius degree. Good. Find the expected change in the freezing point. Again, try to calculate the theoretical delta TF. What do I mean by the theoretical delta TF? It means use the rules that we have studied. Rules for what? For the calculation of delta TF. Because anything that has been calculated using any rule, it must be theoretical, without lab, without any experimentation, of course. So the question said, practically, it has been observed that delta TF is negative 4.78 Celsius degree. Please try to calculate the same delta TF, but this time without any experimentation. The calculated one, the theoretical one, the expected one. Good. And then give the reason if both are the same values or different values. First of all, since the compound is a salt, it's a soluble salt, and it's electrolyte at the same time, so you should write the dissociation reaction. MgI2, after its dissociation reaction, will produce Mg plus 2 and iodide ion multiplied by 2 for the sake of balance. So in total, we have 3 ions, 1 plus 2, 3. So you will get 3 moles of the ions. We have 3 ions. 3 particles, 3 ions. 1 magnesium ion and 2 iodide ions. Okay? Clear? Good. Now, find delta TF. So delta TF equals to Kf times total molar concentration. Don't you remember? Colligative properties depend on the total molar concentration. So what is the total molar concentration? Total molar concentration, it means the concentration of the ions multiplied by the molality. Okay? Look at this. So total molar concentration, it means molality times number of the ions. In somewhere they will say the factor. This is also true, no problem. Good. So Kf is, since the solvent is water, because this is aqueous solution, it means water-based solution. So the solution is called aqueous or aqueous solution for the things that that are dissolved in water. So the overall solution is called aqueous or aqueous solution. Okay, Kf for water is negative 1.86 multiplied by the molality is 1 times number of the ions is 3. So the result is negative 5.58 Celsius degree. So now both values are different. This is delta TF theoretical one, but this is practical one. Let's see what's the reason behind of this difference between the results. Look, MgI2. Okay, first of all, because there's an attraction between the ions, Mgi2, the total attraction. Okay, I'm talking about the total attraction. Be careful. So Mg plus by 2, the charge, I mean, we have two negatives here, one per each iodide, okay? Because, you know, it has two iodide ions together to form I2, so we have two negative. Negative 2 plus 2. Because of this charge, the compounds won't dissociate completely. That's why we will get different results. If you remember last time, I have explained the difference between the practical and theoretical result in a very long detail. I said anytime practical and theoretical result for the electrolytes must be different. Why? Because of the attraction force. Always theoretical one must be greater than the practical. What, mister? Okay, I'll repeat again. Always theoretical result must be greater than the practical result. How? The practical result here, delta TF practical, is negative 4.48 Celsius degree. And delta TF theoretical delta TF, I mean, equals to negative 5.58. Mister, just now you said theoretical is always greater than the practical result. But now, negative 4.48 is greater than the 5.58 Celsius degree. My dear, this is not about the math value of the result. It's about the change. It's about the greatness of the change. It's about the jump, the gap of the result from the real value. Look at this. Water freezes at 0 Celsius degree. At what? 0 Celsius degree. This is freezing point of pure water. Okay? Theoretically, we have expected the freezing point depression is negative 5.58. So this is the theoretical jump. Theoretical jump. Theoretical change. This is the theoretical change. But practically in the lab, the result, it was negative 4.48. It means in somewhere like here, okay, compared to this. Even if it's not accurate, but you know what I mean. Negative 4.48 Celsius degree, get. So this is the change of the practical. Now, which one has a greater change? Which change is greater, the theoretical or the practical? Look, this is the theoretical change. This is the practical change. Mister, hopefully, هیوادارم ئێستا تێگەیشتوی. کورە بابی من مەبەستم لە نرخەکەیان نییە. دەزانم ئەمن گوتم theoretical دەبی گەورەتر بی لە practically. جەنابیشت هاتی دەڵێ Mr. Negative 4.48 is greater than this, which is the practical result. ئەو عکسی قسەیتووە. نا بابی من مەبەستم لە خودی نرخەکەی نییە. مەبەستم لەو گۆڕانکاریەیە کە دروست دەبی. سەیری گۆڕانکاری theoretically کە. This is the theoretical change, this area, but this is the practical change. So which change is greater? The theoretical one. Why? Because of the attraction force. Because of what? The attraction force. Very good. Done. It's time for the last colligative property, which is the osmotic pressure and the process of osmosis. Okay? Osmotic pressure and the process of the osmosis. Okay, look. Be patient, please. Okay, so it's time for the osmotic pressure, the last colligative property. First of all, there's a wonderful note here. Highest osmotic pressure, it means maximum concentration. Okay, from the names, it's very clear to see if the relation between them is direct or indirect. Of course, they have the direct relation. I mean, osmotic pressure is directly proportional with the change in pressure, change in concentration. I'm sorry. Change in concentration. Okay, so as the concentration increased, the osmotic pressure is supposed to be higher, and with decreasing concentration, osmotic pressure is decreased also. So my dears, please try to repeat all the steps here that I'm going to explain. Okay, I will, you know, وێنەی کتابەکەی زۆر جوانە لەگە وێنەی کتابەکەی osmotic pressure explain دەکەم. بەڕێزیشتان محاولە بکەن هەر جارێک anytime when I mention a new point, try to repeat that point after me directly. Stop the video, repeat it, and then, you know, play the video game. Okay. So remember, the topic is colligative property. What? Colligative property. The last one, which is the osmotic pressure. We have two pictures, two graphs here. This is the first one, starting point, and this is the outcome of A. Outcome of the first one. Well, stay with me. The first step, we have a U-shaped tube. The shape of the tube is like U, not U, the letter of U. Repeat after me. The first step, we have a U-shaped tube. What? We have a U-shaped tube like this. U-shaped tube. Then, in the middle of the bottom, we have a semi-permeable membrane. It's like a filter, okay, which is called semi-permeable membrane. What? Semi-permeable membrane. Let's repeat all. U-shaped tube with a semi-permeable membrane in the middle. In the middle. Good. Then, what is the semi-permeable membrane, mister? The definition of the semi-permeable membrane is very important. Look, the term of semi, it means not completely. Something like that can do something into half by half. Okay, look, semi-permeable, it means it's a filter, it's a membrane that allows the passage of some particles. Some particles are allowed to pass through the membrane while blocking the other. Some of them cannot. It's like a checkpoint, okay? It allows to pass something through of it while blocking, bouncing back the others, okay? Got it? Okay. So what is the semi-permeable membrane? It's a membrane that allows the passage of some particles while blocking the other. Okay. Look. And let's read the definition of the semi-permeable membrane. Semi-permeable membrane. A membrane that allows the passage of some particles. Underline this. Which particle can pass? Give me an example. Well, solvent can pass. Example, H2O, the most abundant substance on Earth. So water can pass through the semi-permeable membrane while blocking the passage of the others. Which particle cannot pass? Like solute, such as sugar. A very good point. We have a U-shaped tube with a membrane. Water can pass, but solute, which is example sugar, cannot pass. Let's get back to the picture, to the graph. Good. We have a U-shaped tube with a membrane which is called semi-permeable membrane. So these are questions. Which particle can pass through the membrane? Solvent. Example, H2O. Which particle cannot? Blocked. Solute. Sugar cannot pass through the membrane. The first point is done. Now it's time for the second point. Two equal amounts. We will use two equal amounts. Two what? Equal amounts. With different concentrations. Look, the amounts are the same, but the concentrations are different. So now we have two important points. The first one, there must be a semi-permeable membrane, then two equal amounts with different concentrations. Okay, let's see. Example, here we have pure water, pure solvent, pure solvent, and in the other side we will use the same solvent but this time contained solid. Sucrose solution, solvent, contained solid. Let's repeat all the points, please. We have a U-shaped tube with a semi-permeable membrane. Why do we call this semi-permeable? Because only some particles can pass. Which particle? H2O solvent can pass. It allowed the passage of the movement of H2O through of it, while blocking the other like sugar or solid. Then two equal amounts with different concentrations must be used, or two different concentrations of solutions. It's okay to have two sucrose solutions, but one is more concentrated than the other. The point is, there must be two different concentrations with the membrane. These are the two important points for the process. There must be a semi-permeable membrane with two different concentrations, but the amounts are the same, no problem. Then, once we have these kind of things that are equipped, then it's time for the process, which is osmosis. What is the osmosis? Look, let's compare their concentrations. Since this side is a pure solvent, so we call this less concentration, more solvent, because it's a pure water. This is not good to use the terms of solvent and solid. There's no even any solid. But in case of if it's solution, we'll say more solvent. Here, more concentration. Here we have more concentration, less solvent. Great. Okay, mister. Now we have a membrane that used to separate two different concentrations. One is more concentrated than the other. So what's going to happen? What will be the next step? Then it's time for the movement. It's time for the passage. Water molecules are passed through the membrane, okay? So once we have two separated solutions, one is more concentrated than the other by a semi-permeable membrane, then water must be traveled from which side to which side? From less concentration to more concentration. Water travels from less cons to higher cons, from more solvent side to less solvent side. This process is called osmosis. It's called what? Osmosis. Let's repeat all the steps from the first. We have a U-shaped tube with a semi-permeable membrane, two different solutions. One is more concentrated than the other. Well, okay, for this time we have used pure water, pure solvent, which is less concentrated. The other side, the same solvent contained by solid, such as sugar, more concentrated. Then it's time for the osmosis process. So what is the osmosis? Osmosis is a process of movement. Movement of what? Of solvent particles like H2O. Through what? Through the semi-permeable membrane or the semi-permeable membrane. لما با پروفسور انگلیسی به semi لگ نکاتو باشه جانمن. Okay. Through the semi-permeable membrane. From what to what? From less con side to the more concentration side. Got it? I won't repeat this again. But so now the point is, there must be an outcome for this process, because this is the same that if I take some amount of water from here and then add it to here. So the level here must be decreased and here must be raised. The level must be lowered. Here must be raised. Look. So what will be the outcome of the osmosis? The outcome of the osmosis. Look at this. The more concentration side's level is increased. The concentration is decreased because this is the same if I add some water. So the concentration must decrease. And solvent is increased. Some solvent particles are transferred from less cons to more cons. So the concentration is decreased, solvent is increased. Great. How about the level here? Must be decreased. Look at this. This level must be raised like this. And this level must be lowered like this. Okay? Got it? Let's repeat all the steps from the first for the So we have a U-shaped tube with a membrane which is called semi-permeable. Okay, it's good. So we have a U-shaped tube with a membrane which is called semi-permeable membrane. Good. Then two equal amounts of different concentrations. One is more concentrated than the other. So if we have two different concentrations that are separated by a semi-permeable membrane, it's time for the water movement, which is called osmosis. What is the osmosis? Movement of solvent through less cons to more cons, which makes the more concentration side level must be increased, the less concentration must be decreased, the solvent particles increase, the concentration is decreased. These are super important points. You should know. Okay? اتون خوش دیلوی بانو عیزولو دوباره دکم please. اوج آخر بابتا بله من عجز نبی احتمام چی زوری پی بدین از چپتر یکم دست ری خوی. انشالله بختور دویتن. Good. So now let's see the outcome of the osmosis. Mister, this process will be continued. كره بابی مخو مزخی آوینی هر او برز بی فریبده آی فریبده. باشه بابی من. So it must be stopped at some point because with the elevation of this side, it will produce its own pressure, which is called solution pressure. Once the level is increased, it will produce a pressure which makes the process stop in somewhere, right? Okay. عندما مستر level هر برز دبتو یان دوستی لهندک شوینی بابی من دوستی لهندک شوینی لبرای لیره pressure دروز دبی then اورادوس نتوانی زیادت برز بیتو. But there's a very important point. When the solution pressure is equal to the osmotic pressure, then the level stop from raising. The level what? Stop from raising. So this process won't be continued until this process will be continued until this point. When solution pressure equals to the osmotic pressure, the level will stop from raising. But at that point, the average movement of molecules through both sides will be the same. What do I mean by this? It means if two water molecules transferred from this side, it will send back two water molecules. It means the number of water molecules that go toward the more concentration side equals to the number of water molecules that go toward the less con side. Okay? So in this step, the osmosis process must be terminated. Got it? I'll repeat for the last time. U-shaped tube with a semi-permeable membrane, two different concentrations. It's time for the water movement from less cons to high cons. This process is called osmosis, which makes this level increased, this level decreased, lowered. Then it will be stopped. The process will be stopped when solution pressure equals to the osmotic pressure. So what is the osmotic pressure? It's the external pressure that must be applied to stop the osmosis. So when the level stops from raising, when the solution pressure equals to the osmotic pressure. And what makes the more concentration sides level increase? Water by movement, by osmosis. Movement of water through the membrane from less cons to high cons. That's all. Okay? We have a process which is called reverse osmosis. Look, the process of osmosis is used to the process of reverse osmosis, of course. Now I'll tell you how to get the reverse process of the osmosis. Can be reversed, which is used to purify water from any contamination. Okay, the osmosis process can be reversed by applying a pressure which is greater than the osmotic pressure. So if we apply a pressure which is greater than the osmotic pressure, then we will send back all the water molecules from here to here. Okay, we will force this side by a pressure which is greater than the osmotic pressure, like this. Okay, if I apply a greater pressure, so only water particles can pass through the membrane. So all the water molecules are going to pass through the membrane until we will get pure water here and only sugar molecules here. In this case, water must be purified water. Okay, this is called reverse osmosis. Reverse osmosis. What is the reverse osmosis? The movement of water particles through the more concentration side to less concentration side. Mister. So osmosis is from the less cons to higher cons. But reverse osmosis, it's from more cons, my God, to less cons. The processes are reversed to each other. Great. Keep going. I have explained all the following points here. So why does the level of more concentrated solution raise when two solutions of different concentration are separated by semi-permeable membrane? Okay. level before concentration water movement, solvent movement, which is called osmosis, from less cons to high cons. Okay. When does the level of the solution stop raising? When the solution pressure equals to the osmotic pressure. Okay. When the solution pressure equals to the osmotic pressure. And look at this. We have some questions here. Notes here. Look. What are the reasons of osmosis to occur? There must be semi-permeable membrane and two different concentrations. It means if we have equal concentrations, so there will be no process of osmosis. Then let's read this note. Regulation of osmosis is vital to the life of a cell because, look, let's talk about the cells. The cell membranes are semi-permeable membrane. So if the cell goes to somewhere that has a higher concentration, look at this, Zana. Cell lose water and shrink. And what? Shrink. Something like contract, shrink. When placed in a solution of higher concentration. يعني تسيلي cell كان قريش دبنوا. ئاوی ناویان فرێ دەدەنە دەرێ کاتێک دەستنە شوێنێکی کاوە کۆنسنتریشنی زۆرە بەخۆیان واتە کۆنسنتریشنیان کەم بی. They have less concentration compared to the medium, so they will send their water inside of their area, okay, because of the membrane. I'm talking about their cell wall. Cell wall is a semi-permeable membrane, so they shrink. And if they want to swallow, something like if they want to swell, I mean if they want to babbling qabare and gorebi, they must be in somewhere with lower concentration. So at that time, water from the outside will go to their inside. Okay? Why osmosis is a colligative property? Osmosis is a colligative property, as I said, because the change in concentration affects the osmotic pressure. If I increase concentration, the osmotic pressure must be increased. With decreasing concentration, osmotic pressure is decreased. That's why osmotic pressure is a colligative property. ئەو پرچەشم هەڕێک نەکەت دەزانی گەرمایە So I think I have nothing else to say, but the last thing in this chapter, which is this question, look at this. Which of the following has the highest osmotic pressure? It means the highest total molar concentration. Look, sucrose multiplied by 1 will be the same. Then glucose multiplied by 1 will be the same. Then glucose 0.5 molar multiplied by 1 will be the same. This one also will be the same. So the greatest result shows the highest osmotic pressure. This is the correct answer. هیوادارم لێ تێگەیشتبن. ئینشاءالله باشترین فکرەتان لەسەر osmotic pressure پەیدا کردیە. قوتابیان باوەڕکەن grade 12 chemistry grade 12 بابەتەشی زۆر ئاسانە تەنها وێبڕەک زۆرە. I'll repeat to you, never lose this opportunity in this summer. Please stay with my videos. Use these videos like your private teacher along with my booklet, of course. I'm pretty sure you will see the outcome during the normal days of the school. Okay? So بەقسەی مامۆستای خۆت بکە دڵنیا بە زۆر باش دەبی. See you in the next chapter, inshallah.